Hi, good morning. It's now 10 a.m. in Malaysia now. We'd like to welcome all of you from all over the world. You might be watching live now, or you might be watching later according to your time zone. We want to welcome all of you to the very third International Conference on Sustainable Innovation in Engineering and Technology 2021, SIET 2021. My name is Freddy. I'm the program chair of this conference. You know, this is the third time we have been running this international conference, and the main objective and the aims of this conference remain the same. The main objective of this conference is to encourage and to promote research, innovation, and solution in sustainability development with the help of engineering and technology. Globally, we are now facing pandemic. We might not be able to gather physically, but thanks to the technology, now we are able to gather virtually in this international conference beyond the boundary. Now, despite the pandemic, we are still thankful. We have been receiving overwhelming response from all of you. I want to say thank you to all the participants of SIET 2021 for joining this conference. I want to say thank you not only because of your participation in this conference, but also your participation and commitment to make the world a better place with your research, with your ideas, with your innovation in sustainable development with the help of engineering and technology. Now, first of all, today we want to welcome Professor Engineer Dr. Vinesh. I want to welcome Professor Engineer Dr. Vinesh to join us to deliver his opening speech. Now, before I hand over to Prof. Vinesh, I want to say some introduction about Prof. Vinesh. Prof. Vinesh is a Deputy Vice Chancellor and also a Chief Innovation Officer of SIET 2021. He is also a General Chair of this conference who is crazy and passionate about research and innovation, especially in sustainability development. So he served as the General Chair of this conference, who first initiated this conference to promote and to encourage innovation in sustainable development. Now, without further ado, over to you, Prof. Vinesh.
Right, thank you, Dr. Freddy. A very good morning and a warm welcome to everyone who are online and part of this morning's opening to the Sustainable Innovation in Engineering and Technology Conference, SIET 2021. Yeah. As Dr. Freddy mentioned just now, well, thank you, Dr. Freddy, for your kind introduction. This is our third year running, and this time around, just like in 2020, we are hosting it online because of the current scenario, which has not changed that much since 2020. Better times to come, I hope and pray for. The SIET is our engineering focus conference, which basically stresses on technology and innovation, and we try to inculcate sustainability within the context of engineering and technology as per our university's vision, mission, and goals, whereby we are also a very tech-based university, where our forte is basically technology. So all our programs, research, and infrastructure that we have on campus has got a technology element embedded in it. Yeah, we are the frontiers in technology, and what we do in engineering from a sustainability perspective is to also use technology as a tool to enhance sustainable developments. Yeah. I would like to thank Dr. Freddie and the working committee who have worked behind the scenes to bring this conference alive to this moment, yeah, and to also ensure that we have good participation. So I've been told there are 77 papers which have been submitted for the conference, which is very encouraging. It is a showcase of consistency over the last 3 years. And it has also met our objectives and outcomes for this desired conference. Now, for the conference itself this year in 2021, APU is blessed to have 2 internationally renowned keynote speakers. So up front, I would like to thank Prof. Kyo Beum Lee from Ajou University, South Korea, and Mr. Woon Wei Kian from Tenaga Nasional Berhad, Malaysia. It's our pleasure to bring you on board virtually, and I thank you for your support to this year's conference. Now, I'd like to speak a little bit more as part of the opening. I'd like to stress on research and the future trends for 2021 and beyond, whereby technology, for that matter, is engineered for consumer needs and or human life betterment. Now, taking the current situation of the COVID-19 pandemic, which has been moving very consistently and evolving by itself over the last 18 months, we can see that the future trends in research will cross 3 themes. Yeah. So these 3 themes I'd like to stress on. The first one is people centricity. Now, when I say about people centricity, it's basically the pandemic itself has changed how people work and interact within organizations. People are still at the center of every single business operation, but the way people interact and the way people operate in terms of work deployment and work engagement, this will change as there will be a need to digitalize processes to function in the current environment. So this is where the new term of the Internet of Behavior and AI engineering will be used to sort of ensure that people centricity is intact. The second theme is location independence. Now, the COVID-19 pandemic has shifted how people work, where employees, customers, suppliers, organizational ecosystems, how they physically exist has changed. Now, location independence requires also a technological shift to support this new version of business. Now, this is where the total experience and anywhere operations will come into place. And a lot of digitization will come to support the experience gain, the totality of it, and also being able to work and operate anywhere. Now, the third theme is actually resilience and how resilient our delivery is going to be. So whether there is a pandemic or a recession, or whether there's any sort of volatility that exists in the world today, organizations will always be prepared to pivot and structure against different kinds of weather conditions, yeah, or any form of disruption. So as we move on to the digitization of how we are going to run our businesses, there are a lot of disruptions that come into play, and these are the areas that I would like to see embark in terms of research as well, which is the privacy and enhancing computation, the usage of cloud, if you can say a distributed cloud. Yeah, we know that cybersecurity is strong in many business ops, but the use of cybersecurity mesh will become more. And of course, to make things more efficient and productive, hyper automation will come into play as well. So in summary, the three themes are basically people centricity, location independence, and resilient delivery. I think these three areas are areas where technology will be further engineered for customer needs and human life betterment. So in short, I'd like to thank again the keynote speakers for the conference this morning, and Dr. Freddie and the working committee for setting up the conference and running it smoothly as we envisaged. And I thank all the participants who have submitted papers, all 77 of them. And I wish the conference a very good journey this day today. Yeah. So thank you, and over back to you, Dr. Freddie.
Hi, thanks, Professor Engineer Dr. Vinesh, for the opening speech. Now, just for your information, all the presentation and all the presentation by the authors are pre-recorded and uploaded in our official website, protected with password. Now, they are only made available to the participants of this conference only. However, the good news is that now the keynote speech are made available to the public for the benefit of everyone. So now come to the highlight of this conference. As Professor Vinesh has said, we are very honored today. We have two keynote speakers joining us. One is Professor Kyo Beum Lee from South Korea, and Mr. Woon Wei Kian from TNB. So first of all, to begin with the keynote, we would like to welcome Professor Kyo Beum Lee from South Korea. So Professor Kyo Beum Lee received his bachelor and master degree in electrical and electronic engineering from Ajou University, Suwon, South Korea in 1997 and 1999 respectively. And after that, he received his PhD degree in electrical engineering from Korea University in Seoul, South Korea in 2003. So from 2003 to 2006, he works in Aalborg University, Denmark. From 2006 and 2007, he then now moved to Chobon National University in South Korea. Since 2007, he joined Department of Electrical and Computer Engineering in South Korea, where he served as a professor now in Ajou University. Professor Lee research include electrical machine drives, renewable energy power generation, and electric vehicle application. He is an associate editor of IEEE Transaction of Power Electronics, IEEE Transaction of Industrial Electronics, Journal of Power Electronics, and Journal of Electrical Engineering and Technology. So we thank you, Professor Kyo Beum Lee, once again for your keynote speech. So over to you, Kyo.
Okay, good morning. And then, can you see my presentation file? Okay, it's great. Okay, good day, everyone. I'm Kyo. You can call me just Kyo. Beum is not easy to pronounce. And then Kyo from Ajou University in Korea. Today's topic is reliability in power conversion or power electronic systems. In this presentation, I will cover the introductory information on reliability of Igbt switch, capacitors, and some researches about reliability improvement for power conversion system. Okay, this is content of this presentation. First, I will start with introducing my laboratory and the project we've done, and then I will talk about reliability of power conversion system, Igbt module, capacitor, or some existing method to improve reliability of capacitor, and then summary. Oh, sorry. Okay. These are the member composition and the research area of power electronics lab. We have, sorry. 32. We have now 32. Sorry. We have now 32 members. One is assistant professor from UTM. He's from UTM, and then one research professors. We have also 9 PhD students, and then more than 20 master students. Okay, and based on power electronics, we study various fields such as electrical vehicle and motor drives, and the reliability, and the renewable energy system. If you have any question or any comment, any information, you can send email to me directly, and then we can talk by email. Well, we we have 3 laboratories. First one is power electronics, and the second one is green energy lab, and the third one is power conversion R&D center outside of my university. Okay. And then for 3 years, we have more than 80 international papers, and then more than 40 conference papers. These are 4 pictures of my laboratory. This picture is quite interesting. I took this picture in Indonesia. The mountain. I cannot remember the name of the mountain. The mountain is kind of a volcano, but I visited there, and then I shared very good time with my lab members. The conference name is maybe CENCON. Yes, CENCON 2019. It's a domestic conference, some sports game, and then graduate ceremony in my laboratory. And then it's my students are now working. But from this slide, I will share some information about the research project of my laboratory. Okay, first of all, I have just to finish this energy management algorithm development for hydrogen fuel cell railway. Sorry. Oh no. Oh, it's a later car, but the second one first, and then so railway car. And this project was developed grid. Sorry. Okay, this project was developed with the grid-connected back-to-back converters, and the project helped out the laboratory to improve back-to-back converter configuration and operating sequence analysis. And then the second project is the fuel cell railway car. And the next slide is motor drive, the sensors control and rotating restart technique for permanent magnet synchronous drive system. And also, one of the main researches in my laboratory is some charging system. So this project is co-worked with some other university in Korea. The multi-port fast charging system is started with newly made some switching device, SiC, silicon carbide switching devices, and many some interleaved modulation techniques for DC to DC converter system. Okay, this is the silicon carbide switching device, the 3-level inverter system. We made some small prototype in my laboratory, and then we gave some knowledge to some kind of company, LS Electric, and now they are now making their product. We demonstrate proper filter materials and then 3-level topology depending on the experimental result. Okay, we are now doing many research projects, some solar signage, and then intelligent power module for a motor drive, and also what's that? Some modularization for power conversion system, and also some reliability improvement by some junction temperature measurement. And then it's also for EV fast charger. It's okay. If you need any more information about our project, send me email, and then I will introduce more detail about my project. Okay, let's start my presentation now. The first topic is what is reliability, and then I'm going to talk about the necessity of reliability research, classification of reliability research, and then reliability of power electronic system, power conversion system. Okay, what is reliability? Reliability in a power conversion system is defined as follows: the probability that an item will perform a required function without failure on the stated condition for stated period of time or available lifetime of system. In short, the probability of a system failure or knowing the time when it will fail. If we can know whether the system will fail, we can prevent various accidents by repairing the system in advance. The below figure is mainly caused by user mistake. Below figure shows the failure rate of the power electronic system. Just to look at the trend, the first early failure is mainly caused by user mistake. So the failure rate is relatively high at the beginning of the system operation. It's early. And then the next is unpredictable failure or trouble. Even in the normal operation, the probability of failure is not completely zero, so some degree of possibility of failure should be considered. The last is wear-out failure. You can see that the failure rate increases due to wear-out. Wear-out failure will be covered in detail later. So in this presentation, we will focus on the wear-out failure. This shows why reliability research is necessary. The power system is composed of various components such as generation station, transmission line, transformer, and power conversion system. Among these components, the failure rate of the power conversion system occupies a large proportion. For example, in a PV system, the failure rate of power conversion system is around I think more than 37%. Therefore, to improve the reliability of power system, it's essential to improve the reliability of power conversion system. This figure is the classification of reliability research field. All of the classified research fields are being actively researched now. Okay. Power conversion system is composed with the various devices. It can be divided into source, power electronic circuit, controller, and load. the more than 50% of fault of power conversion system is caused by the capacitor and power device in a power electronic circuit. The failure of two main components deteriorate reliability of power conversion system. Okay. The main stressor induced the failure of devices is thermal stress. Oh, okay, you can see this blue box. At below left, the stress of power conversion system components are shown in the table. The main is temperature. So now we will focus on some temperature of some power devices. Okay, next I will talk about some introductory for the reliability of IGBT module. In this chapter, I will explain IGBT module failure mechanism and the press for reliability analysis of IGBT modules. Okay, next slide. Okay. IGBT module is one of the famous semiconductor devices in power conversion system. Generally, IGBT module has multi-layer, which is composed of materials with different CTE. CTE means, coefficient of thermal expansion. Okay, the main reason of IGBT wear failure is repeated contraction and expansion due to thermal stress on the layer surface between materials with different CTE. This figure, this figure shows IGBT module structure and different CTE of each layers. The bond wire is 23.5, chips. Silicon is around 2.6. Different to CTE, it's caused some wear failure in IGBT modules. From this slide, I will talk about the failure mechanism of IGBT module. There are 5 causes. First is bond wire fatigue. This fatigue is caused by the temperature of aluminum wire and silicon chips with different CTE. The thermal mechanical stress lead to lift up. You can see this figure, this photo, and the lift up failure of bond wire as shown in the light figure. Next is, metallization deconstruction. Metal layer is joined to IGBT chips for electrical connection of IGBT and module component. The temperature, the temperature variation of metal causes tensile stress of metal. If the elastic limit point is exceeded, the metal cannot be restored to the original state. It leads to increased metal sheet resistance and the weak electrical connection to metallization. Okay. Okay. In this figure, I will talk about a third, a fifth, or a fourth and fifth failure mechanism. IGBT module has solder joint between IGBT chips and DCB, or DCB and base plate. Okay, the temperature variation of solder joint leads to thermal mechanical stress and IGBT thermal impedance increase. It can promote the crack of solder joint and another failure mode of IGBT module. The next one is gate oxide failure. This faulty oxide film of gate caused this failure. No photo. It can be occurred when a high field is applied or when a low field is applied for a long time and the injected hot carrier with high kinetic energies. The last thing is burnout failure. It is caused by extreme fatigue in a short period of time. It generally caused by short circuit situation. Okay, this table shows the mechanism of Igbt module failure and the main causes. Most Igbt failures are due to the material degradation caused by junction temperature variation. So the measurement of junction temperature or estimate junction temperature in Igbt is required for the light prediction reliability reaches of Igbt. Okay, this figure shows some kind of circle. Okay, to improve the reliability of Igbt, the process will be required to design power conversion system. As mentioned before, the analysis of temperature is important for power conversion system reliability. By using thermal model, by using thermal model, the temperature profile can be obtained from power loss profiles. An accelerated aging test is required to obtain the Igbt lifetime model. After that, we can estimate the lifetime of Igbt module for lifetime model. The lifetime estimation is an important procedure to improve reliability of Igbt. Okay. Sorry. Sorry. Okay. Sorry. This chapter. Okay. About some reliability of capacitor. From this slide, I will talk about capacitor. As I told you before, capacitor is the most frequently broken devices among power conversion system component. Therefore, I will focus on the capacitor. I will explain the type and characteristic of capacitor in power electronic system. As you know, I will analyze in power electronic system rather than an analyze on chemical properties of capacitor. Okay. This is the structure of aluminum electrolytic capacitor. Aluminum electrolytic capacitor is composed with aluminum electrolytic solution, the oxide film as shown in the figure here. The main factor of capacitor is capacitance, ripple current rating, and the volumetric efficiency. In power conversion devices, capacitor should be selected considering these main factors. There are various kinds of capacitor. I will talk about later the characteristic of each capacitors. Okay. Maybe I was just only 20 minutes. In this slide, okay, I will talk about some classification of capacitor. Okay, we can classify into fixed type, variable type. Among them, fixed type capacitors such as ceramic, film, electrolytic capacitor are widely used. So, okay, the fixed type. Ceramic capacitors have no polarity and a material with a high dielectric constant such as barium titanate is used as dielectrics. Because of its high frequency characteristics, it's widely used for noise removal. Okay, ceramic capacitors, noise removal. The film capacitor also have no polarity. Polypropylene is used as dielectrics. Electrolytic capacitor use a thin oxide film and aluminum as dielectric and an electrode. The dielectric inside the electrolytic capacitor can be made thin, so the capacitor volume ratio of electrolytic capacitor is very large. So electrolytic capacitor has polarity and outstanding low frequency characteristics, so it's widely used for rectifier and the low frequency bypass. So, in a power electronic system, we usually use some electrolytic capacitor for rectifier, some other application. Also, there are many types of capacitors, such as capacitors. Many related materials are on the internet and in books, so it's recommended to study further. In fact, when designing a capacitor, we have to consider a number of factors. I told you before about the main factor in slide 10. Okay, slide 10 or slide 10. Capacitance, ripple, no, slide 10, not, sorry. Slide 29. Sorry, not 10. Slide 29. Okay, slide 29. Capacitance, ripple current rating, volumetric efficiency. Okay. It must be designed by comprehensively considering various factors such as voltage rating, capacitance stability, ripple current rating, temperature, and ESR. Also, it's very important to consider volumetric efficiency, lifetime, and cost for improved system power density, reliability, and cost competitiveness after the capacitor specification is designed. Okay, let's talk about how we can capacitors in power converter system, power electronic system. These are two examples. Motor drive, of our figure is motor drive, and then the lower figure is PV, photovoltaic system. We use the capacitor in motor drive system as an EMC filter, DC link, DC source, and alpha filter of inverter. In the case of photovoltaic system, we also use in various ways as EMC filter, DC link, and filters. In other words, a capacitor is a device that plays an important role in a power electronic system. We will continue to focus on capacitors used in a DC link. Okay, we mainly use film capacitor, ceramic capacitor, and electrolytic capacitor in DC link. This figure shows the comparison of various characteristics of each type capacitor. Film capacitor, had a long lifetime, excellent ESR. ESR means equivalent to series resistance characteristic, and high allowable ripple current and the voltage rating. But they are bulky and vulnerable to high temperature. Ceramic capacitor middle, are relatively small in volume and withstand high temperatures compared to film capacitors, but they are, expensive. Electrolytic capacitor is one of the capacitors which were very popular in this week because of its low price and the small volume, but the ESR is relatively large. The allowable ripple current is small. The lifetime is short because of the possibility of electrolyte vaporization. Look at the failure mode. There are failure mechanism and critical stress according to the type of capacitor. Aluminum capacitor stand for electrolytic, MPPF stand for film, MLCC stand for ceramic capacitors. First, there are 3 types of capacitor failure, such as short circuit, open circuit, and wear-out failure. All the 3 types of capacitors are dominant in wear-out failure. Also, in case of aluminum or MPPF capacitor, the open circuit failure is dominant and the short circuit failure is dominant in MLCC capacitor. The temperature and the voltage are common stressors for each type of capacitor. By type of capacitor, aluminum capacitor is vulnerable to the current stress, MPPF capacitor is humid, and the MLCC capacitor is vulnerable to mechanical stress. Before this slide, I talk one more. For the self-healing capability, MPPF capacitor is the best, MLCC capacitor is the worst. Self-healing here refers to automatically recovering some insulation properties by scattering deposited metals when an accident occurs due to internal or external causes. Self-healing prevent a secondary accident of capacitor to prevent the spread of accident. We will focus on aluminum capacitor with the shortest life among capacitors. But it's moderate and then wear-out failure, blah blah, some cheap price. So most of some application areas, we use some aluminum capacitor. So that's why we will focus on aluminum capacitor. One of the main problem of aluminum capacitor is some short lifetime. So we will focus on some extend the lifetime of the capacitor. Okay, I told before some aluminum capacitor has high ESR and the low permissible current ripple. When a large ripple current is applied on the capacitor, high electrical loss occurs due to high ESR, which causes heating inside the capacitor. Increased heat makes the electrolyte to vaporize faster, or that means which accelerate the wear-out failure of the capacitor. Okay. Okay. Let's take a closer look at the 3 failure mode that can occur in aluminum capacitor. In fact, short circuit failure is not a dominant failure mode. the short circuit failure. So this failure mode is mainly caused by defect in capacitor itself. In the case of open circuit failure, it can also be caused by manufacturing defect and also occurs during unstable control. Above two short or open circuit failure, above two failure modes can be considered as some controllable failure. And it means that we cannot control or manage these two failures. We focus on wear-out failure caused by unstable or unsuitable control and high temperature humidity. We can control the operating environment to delay the time of failure or predict the lifetime. The table below shows the capacitor, aluminum capacitor's dominant failure mode, mechanism, and stressor. Okay, I will speed up. Okay, this shows a short circuit failure of aluminum capacitor. This shows some waveform of open circuit failure. Okay. We jumped the 39th slide. Okay, this is the wear-out failure of aluminum capacitor. The capacitor wear-out failure, this capacitor wear-out failure can be caused by evaporation of electrolyte. The core temperature of capacitor increase due to the ripple component of the current following through the capacitor, which causes the electrolyte to evaporate to the capacitor. The next cause is the decrease in positive and negative foil capacitor. The positive foil is reduced by an excessively high applied voltage, and the negative foils is reduced by applying negative voltage, which does not match the polarity of the aluminum capacitor. Last cause is the high ambient temperature or humidity. You have to know that some wear-out failure is mainly caused by operating environment and caused by increasing capacitor and ESR. In general, the lifetime prediction of capacitor is to predict the lifetime of wear-out, not short circuit or open circuit failure, which are accidental failure mainly caused by manufacturing defect. So we'll focus on some wear-out failure. Okay, this table shows the failure criteria. Okay, we passed. Okay, in this slide, this is the reliable design procedure of this link in the power electronic system. The first, higher level definition. Second, this level definition, capacitor type selection. And fourth, electrical analysis and design. Okay. And then fifth, thermal analysis and design. And the sixth, reliability analysis and design. The seventh, and then robustness analysis and optimization. So lifetime of power electronic system, the capacitor component is very important. So at the first stage, we have to design capacitor with the reliability. We have to consider reliability. Okay. The last chapter, in the previous chapter, I will talk the need for the reliability research based knowledge of capacitor and reliability. This chapter, I'd like to say about some studies to improve some reliability of capacitor. Okay, move. Okay, first is lifetime prediction. As an analyzed in the previous chapter, the lifetime prediction of a capacitor is to predict the time when the wear-out failure of the capacitor occurs. So first step to lifetime prediction is electrothermal analysis. Okay, we move. And then second, nonlinear damage accumulation analysis. And then also we use Monte Carlo simulation and prediction of lifetime. That's the kind of procedure for lifetime prediction for a capacitor. Okay, from this slide, I will talk about minimization of DC capacitor. There are many research results about the capacitor minimization for quite a long time. The purpose of minimization of DC capacitor is to apply high reliability capacitors such as the film capacitor. First, the minimization of DC capacitor is largely divided into three categories. There are performance trade-off, passive, and active method. Among them, various methods have been studied for passive and active minimization method. Many air conditioning system, so outside compressor. The Korean company used some chemist topology. That means a very small capacitor to improve the lifetime of power conversion system. Okay. I told you this slide. There are passive approach and the active approach. Okay. And then this is condition monitoring. We have to monitor the condition of some capacitor, and then we can find some solution to improve their lifetime or something. Okay, there are some method to monitor some condition of capacitors, and also some kind of some improved algorithm, some neural net or something. Okay, we moved. And then, okay, it's research result in my laboratory. So lifetime extension of capacitors, the first method. We can make some modified PWM method, and then we can reduce some current ripple to flow into capacitor, and then we can extend the lifetime of capacitor. Okay, we can also show some readers evidences by experiment. As a second method, some different vector choice, and then we can reduce also some different system, and then we can reduce some current ripple to capacitor. Okay, this is summary. First, I introduced the necessity of studying reliability of our power conversion system, and then focusing on reliability mode of Igbt module capacitor, which has been dominant role of the power conversion system fault. And we have looked about the reliability improvement of power conversion system with the failure tolerance and the reduced neutral point current. Okay. Next is the references. This is my book, the Reliability Improvement Technology for Power Converter. And then there are some manual references, and then you can find this paper to understand my presentation. Okay. This is.
Thank you, Prof. Kyo.
Yes.
Thanks for your keynote. So there are some questions by the audience. So let us pull up the question and let's see the first question. So can you see the question?
Okay.
So
Since
just people,
I can read. Since the reliability of IGBTs is most decreases by junction temperature, what's the reason of increases junction temperature? What's the solution? You know, some module company, device company, some now making some sensing some junction temperature, and then some academical approach. We are now making some summer model. That means we can estimate junction temperature. So we can estimate junction temperature, and then we can monitor junction temperature without sensing. It's okay. So, and then some exceed some critical value, some switch devices can be broken. So before that point, we can make some we can start some method to stop the power conversion system. Can you understand?
yeah. So you're saying that you're trying to do some thermal modeling to predict the junction temperature. So before it reaches the critical value, so you can do something in the power electronics converter so that you minimize the junction temperature.
Oh, yes.
Yeah. So thank you, Prof. Kyo. And let's limit it to another 2 questions because of the time. We have two more. Okay, let's see this one.
Okay, switching loss is somehow increasing the temperature of switching device. May I know how should we decide the best switching? It depends on some application area or power electronic system. And then home appliance area, we have to use some high frequency because of some kind of noise can cause some problem in the human ear. Did you understand? We have to some high switching frequency. When some transaction, when some train system, because of the switching device, we have to some low switching frequency. It depends on application area, cost, power density. So we cannot decide some switching frequency or some academical approach, some application area, and the cost to switching devices, and that's okay.
Yeah, I agree with you. So maybe we have another 2 more questions before we end your session, Prof. Kyo.
Yes.
We have one. Okay.
Since losses are somewhat of concern power efficiency, what's the stop range of efficiency?
I think maybe the question is asking how many percent, what is the minimum efficiency?
Yes,
how many percentage?
It's the losses in the power electronic system. Losses mainly causes by some switching devices, so it's depend on some power density and cost. If we can use some very expensive switching devices, we can reduce switching loss and conduction loss. That means some improved power density and good switch efficiency. But I cannot make sure, but it depends on some application area.
I see. It depends on application area. So there's no standard saying what is the minimum efficiency for power converter.
Oh, yeah.
I see. Maybe we have one last question. Is a little bit of electronics. May
I know? I cannot answer right now because What's the means? Usual gate oxide thickness of Igbt. Now, you can send me email. I have to find some books about some switching devices.
Yeah, I understand.
Okay.
It might be because it might be beyond Prof your
Okay.
area. Okay. Maybe so it's 11 a.m. in Malaysia time now. So we thank you, Prof Kyo, for
Thank you.
your kindness and to deliver your keynote. So before we move to the next session, maybe we take a 5 minutes break before we switch to the next speaker by Mr. Woon Wei Kian from TNB Malaysia. So thank you, Prof Kyo.
Okay.
And stay safe and healthy, Prof Kyo.
Oh, thank you. See you.
See you. Thanks everyone for your patience and for your information. If you are watching live now or if you have just joined us, Professor Kyo Beum Lee has just delivered his keynote speech regarding the reliability in power electronics. So if you have missed the session, don't worry. You can view the recording later in this channel, either in the YouTube or in the Facebook later. No worries. So right now, we will proceed with our second keynote of this conference of the day. Now, we are very honored to have Mr. Woon from Tenaga Nasional Berhad in Malaysia joining us to share his keynote today with us. Thanks, Mr. Woon. So, let me give you a brief biography about Mr. Woon. Mr. Woon Wei Kian is a leading team responsible for crafting corporate strategies in Tenaga Nasional. He started his career as a network engineer and a manager at University Tenaga Nasional before making a switch to TNB or Tenaga Nasional Berhad to work on a smart meter pilot project. He has since involved various roles with Tenaga Nasional Berhad, including leading a project to craft TNB's digital strategy. His current role requires him to have a wide-ranging expertise of the electricity supply industry, from generation to grid and retail, as well as being in touch with the latest industry and technology developments. Mr. Woon graduated from Imperial College of London with a first-class honor degree in Information System Engineering. He holds an MBA from University Tenaga Nasional and Melbourne University School. So thank you once again, Mr. Woon, for joining us in this international conference. So over to you, Mr. Woon.
Hi. Good morning. Let me do a sound test. Do I sound okay, everyone? Can you hear me?
Yes, we can hear you loud and clear.
Okay, great. Thank you. Okay, so very good morning to everyone. And first of all, thank you very much to Prof. Vinesh, Dr. Freddy, and the rest of the UPIT team for the invitation and the opportunity to be able to present as the keynote speaker at this session. Now, thank you very much also earlier to Prof. Kyo for that highly technical and interesting presentation. So for this morning, I'm going to move on a slightly different topic area, which is of course more towards where I am more familiar with, which is with regards to the electric supply industry. Now, my topic of choice today would be to give an overview of the innovation, some of the innovation that's happening within the electric supply industry. And hopefully by the end of the presentation, everyone will be able to see that the electric supply industry, in particular in Malaysia, is also developing and also innovating at perhaps a slightly slower pace, but nonetheless, we are doing our best to innovate and to adapt to get ready for the future where everything is being disrupted by technology and various other forces. All right. Before I go on any further, of course, just a bit of introduction to myself and also my company. So I'm currently serving as the lead for strategy intelligence and strategy formulation in Tenaga Nasional. Now, for everyone here who is watching this session live, if you are staying in Peninsular Malaysia or perhaps in Sabah, you will probably be one of our customers, of course, because Tenaga Nasional is, at the end of the day, we are still a vertically integrated utility that's operating primarily in Peninsular Malaysia and Sabah, and with an international footprint as overseas. All right, so if you can see on the slide, we have around 10.08 million customers, covering both domestic, commercial, mining, and industrial customers across Malaysia and Sabah. And we have various subsidiaries that are involved in different areas of the electric supply industry, from the power plant operation maintenance to engineering procurement, even a subsidiary that's looking into telecommunications and internet connectivity. We also have some subsidiaries that are able to provide energy solutions like solar PV and so forth. Okay, so all in all, we are quite active across the entire ESI value chain, from generation to transmission to distribution and to retail. Okay, so if you need to know more about our company, do visit our website at www.tnb.com.my. Okay, all right, so that's a bit of a promotion for my company. All right, so let's move on to the topic of the day, which is with regards to innovation in the electric supply industry. Now, when we think about innovative companies, generally these names would usually pop into your mind. Probably, you might be thinking about companies like Google, right, who provide us with the de facto search engine of the internet. You probably be even thinking about companies like Netflix, okay, if you like to watch all the streaming videos, or Sony, Alibaba, even Pfizer, who came up with the vaccine for COVID-19, right? So all these companies probably are among the top of the list when it comes to innovation. Now, but when we talk about utilities and companies in the electric supply industry, perhaps this may be much less prevalent. So, I mean, there are so many companies and utilities in the electric supply industry. I've just listed a couple of them on the screen, including, of course, my company, Tenaga Nasional. Now, when we talk about companies like EDF, NetSera, Enel, perhaps innovation may be something that you would not associate directly and immediately with these companies, okay? Because usually when you talk about innovation, it's usually the fast-moving industries like the tech industry or the e-commerce industries and so on. But when it comes to utility, electric supply industry, perhaps, maybe not, right? But hopefully by the end of this session, you guys will be convinced that utilities and companies in the ESI are doing something to move and keep up with the pace of innovation that's happening around us. Now, when we talk about the electric supply industry today, what we can see is that, of course, we are facing a plethora of disruptions. Essentially, there are so many different forces that's converging and essentially forcing and compelling the industry to change or to be changed. Now, we can summarize it into what I call the 4Ds, right? So this is probably something that you have heard. The 4Ds here stands for decarbonization, deregulation, digitalization, and decentralization. Let me talk a bit in each of these areas for a moment. Now, when we talk about decarbonization, of course, we know that right now there is huge pressure to the entire industry to actually start shifting what we call to start participating in the energy transition. In other words, to shift from a traditionally emission-intensive fuel source into something that is less so. All right. In other words, to pivot from a fossil fuel generation into perhaps something like renewable energy and so on. And this is likewise something that is happening across the breadth of the industry. It's not privy to the Tenaga Nasional alone. It's definitely happening globally, and I think all of you here in the industry, in the education world, are aware of it. Now, and of course, along with the pressure to decarbonize, there is ESG concerns, or environmental sustainability and governance concerns, are definitely rising up among all utilities to-do items. And apart from that, of course, utilities also have a lot to worry about when it comes to climate change. We operate power plants, we operate transmission lines, we operate substations, and all these assets are in some way or another susceptible to the effects of climate change, depending on how much climate change we are talking about. So definitely this is something that utilities and electric and companies in the ESI are worried about. And at the end of the day, we do not just worry about the environment. We need to take a look at something called the energy trilemma. In other words, we need to make sure that at the end of the day, we can safely balance the importance coming across the economics of energy generation or energy supply, the sustainability of it doing so, and the security, making sure that the energy supply continues to be there and continues to be available to all. So that is on the decarbonization, the first D. On the second one, on deregulation, this is something that is also affecting the ESI globally. Now, perhaps much more so in the Western world. Essentially, when we talk about deregulation, is the point where the electric supply industry is gradually being liberalized. In other words, it's being opened up in order to introduce more competition and additional market mechanisms being put in place in order to improve the economic efficiency of the industry. In Malaysia, right now, we are still not fully liberalized. Tenaga Nasional is still the de facto utility in Malaysia, and we are operating across the GTDR value chain, but it's not to say that we are monopoly across. For example, in the generation business, we also have the so-called IPPs or the independent power producers, and but across the other parts of the value chain, in Peninsular Malaysia especially, of course, we are still the number one utility there. Apart from that, what we see, of course, that when it comes to the pressure to deregularize, this is something that is not just going to be here in Malaysia as well, but it's also happening elsewhere across the region in Southeast Asia. Now, on the third part, we talk about the third D, which is digitalization. Is something that I am quite passionate about, and it's something that is happening regardless of whether you want it or not in the ESI. Now, when it comes to digitalization, it's the thing that is driving a lot of the innovation that's happening within the ESI. Okay, and it covers almost all areas and all parts of the value chain. And this is something that I'll share a bit more about what Tenaga is doing as well in the area of digitalization later on in my presentation. Okay, so stay tuned for that. And last but not least is the pressure of decentralization. Now, when we talk about decentralization, essentially this is referring to the fact that there will be more and more distributed renewable energies entering into our grid. In particular, for Malaysia, anyway, solar PV or solar photovoltaics. Now, energy generation or electricity generation used to be confined to the larger capacity power plants. Those huge power plants that burn coal or nuclear. Not nuclear, you don't burn it, but gas and so forth. But nowadays, we are starting to see an increasing proliferation of distributed solar photovoltaics, even in Malaysia as well, with the introduction firstly of the feed-in tariff and subsequently the net energy metering scheme by SEDA. And this is definitely a trend that we see that will continue to grow, along with the growth of other supporting technologies like energy storage and digitalization as well. Okay, so to summarize all this, these are the 4 Ds which are reflecting the ESI, and in a way they are causing the industry to innovate or be innovated. Now, to sum it all up, we can actually look at the innovation landscape for the electric supply industry. With the combined forces of all the 4 Ds coming across, there is a need for the utility or for the company in the ESI to innovate and to change in order to adapt to all these disruptive forces. Now, to summarize this, you can refer to the 30 different key innovations that's happening across the ESI. This is something that we took from IRENA, all right? However, to contextualize it in the context of Malaysia, I tried to actually group it into something that will be more immediate and near term, as well as something that perhaps will have a more sort of like a medium term impact horizon. In other words, something that's happening 4 to 6 years down the road. So immediate and near term will be something that's happening now. In other words, the utility or the company needs to innovate and adapt to it immediately, versus something that's in the medium term. In other words, the company needs to start preparing, start doing some pilot projects, starts doing their R&D in order to understand and to develop the competency and the capability to manage it 4 to 5 years down the road. And of course, there are also the other bucket of innovation or technology, which is something that needs to be done, but perhaps at a slightly further horizon. Okay, you may or may not agree with me. This is my perspective. So let me just click on to actually show what we think is going to be impacting the Malaysian electric supply industry, both in the immediate to the medium term. So to the ones in the longer term, I'm not going to cover in this speech. Otherwise, I think in this presentation, I will require another 1 hour to 2 hours to do that. However, I just wanted to highlight a couple of the interesting or the couple of the major innovations which we feel that is definitely impacting the ESI. And just to give a coverage to everyone to tell what is actually happening in the Malaysian industry with regards to these technologies, business models, market design, as well as system operation. Okay, now if you take a look at the slide on the screen, there are a couple of innovations that we would like to talk a bit further on. Let's take a look at each one of them in particular. Now, the first one that we would like to talk about, of course, is batteries or energy storage systems. Now, energy storage system is a core technology that is definitely impacting the ESI across the entire value chain. Now, if you can see on the slide here, what we have is a typical ESI value chain consisting of the system operation, going down to generation, to the transmission and distribution, right to the commercial, industrial, residential, as well as the transportation sector, which is more on the end user side or the retail side of things. Now, when it comes to this value chain, what we see is that storage is something that will be impacting across the entire value chain from the beginning to the end. There are so many different use cases that can be met by storage, ranging from ancillary services provided in order to support a stable and reliable grid. Things like frequency regulation, spinning reserves, ramping services, voltage support, and so forth, right down to generation, where storage is required in order to help maximize the generation of, especially of variable renewable energies, okay, to be integrated along with them, for example, in order to reduce curtailment and also for capacity firming. Going to the transmission and distribution level, you're talking about the integration of storage in order to help manage power quality, to help manage load congestion, and also to assist in the possible deferral of transmission and distribution equipment upgrade. Likewise, when we move to the so-called the end users, to the commercial industrial customers, to the residential, to the transportation, storage also comes into play in order to help with the demand management, with the reliability of the electricity supply, with even going off grid, for example. You definitely need storage in order to complement your renewable, your distributed solar photovoltaics for that purpose. Okay. Now, if you look into the Malaysian context a bit more, this is actually a slide that we took from the ST website, where they actually published a report to talk about what are the electricity capacity requirements and projections coming across the years. Now, what we see is that based on the ST report that was just published in 2021, is that they believe that the RE capacity mix in Malaysia is projected to increase by around 40% by 2035. Which is something that is positive in the longer run. Obviously, with more RE in our generation, we can effectively start decarbonizing our grid, decarbonizing our energy supply industry in order to reduce the greenhouse gas emissions coming across the nation. And along with this, what we hear from ST is that there will be there's a plan to introduce around 5 units of battery storage with a capacity of around 100 megawatts each to be installed gradually on an annual basis from 2030 until 2034 onwards. And prior to that, there will be a pilot project for grid-connected storage to be carried out by the grid system operator before that, in order to develop the capabilities and the competencies to be able to, and also to understand the intricacies of integrating storage into the grid. Now, so what does that mean to us in general? So in that sense, the implication, of course, if you look at this projection, is that what we see is that potentially there may be no major utility scale storage in the pipeline from Malaysia, at least until 2030, based on ST's projection. And that utility scale storage will continue to remain an R&D or research and development item, at least until 2030 in Malaysia, unless something happens. In other words, some major regulatory changes happen. The ST decides that there is a need for us to actually introduce storage earlier, due to, for example, the increase in solar and also other REs in Malaysia. Okay. Now, the other thing that I would like to talk about is, if you notice on the slide, going back to my presentation, there is also another area which is quite interesting, which is of course electric vehicle. Now we know electric vehicle is something that is of interest, that is happening globally. Right now in the global market, ICE vehicles, or in other words, internal combustion engine vehicles, are still prevalent, are still mainstream. However, what we see is that with the growing desire to decarbonize the transportation sector, electric vehicles is definitely coming into play. Now, when we talk about the innovation that's happening on EVs, of course, one of the areas that we can be looking into will be something called EV smart charging. In other words, when you talk about smart charging, is essentially the ability to control the charging of the electric vehicles. In other words, it's not just a dumb equipment that's supplying electricity to charge an electric vehicle, but it's actually an asset that can be controlled, that can be managed through the use of various technologies like what we call the V1G, which is essentially unidirectional control. In other words, the charger can actually be controlled remotely in order to manage the demand and the charging rate. There are other technologies along the EV charging technology landscape, V2G, which stands for vehicle to grid, V2H, vehicle to home, and V2B, vehicle to building. Essentially, they are all dealing with bidirectional flow of energy coming across. In other words, the charger is not just used to charge the battery, but the battery can actually supply electricity back to the grid for different purposes. For example, as part of a virtual power plant and others. Okay. Now, of course, there's a lot of benefits to having EV charging. Namely, you can possibly control the network congestion that is bound to happen at the distribution level if there is a huge increase in the number of EV chargers across a neighborhood. It can also be used to provide ancillary services. However, this one is subject to the introduction of an ancillary market mechanism in the Malaysian electricity supply industry. Okay, and other purposes as well. So in order for smart charging to happen, there are a lot of enabling factors that need to take place in order for this to actually work out. Just to give a very quick snapshot of what's happening in the Malaysian context when it comes to electric vehicles. So right now in Malaysia, we do not have a lot of EV, let's be honest about it. And if you look at the number of battery electric vehicle models in Malaysia, it's really quite limited and it's still a bit high price, and hence along with the price as well as the number of EV chargers available in the public, these are some of the barriers which are stopping electric vehicles from taking off. But hopefully, this is something that will be changing in the near future. Okay. Now, the other thing that I would like to talk about, of course, there are the Internet of Things and AI and big data. These are something that is really impacting the electric supply industry. Hence, I will talk more about this in greater detail later. However, I would like to talk a bit more on some of the innovations happening at the business model end as well. Now, there's something called the energy as a service, which is one of the top innovation that has been identified by IRENA. The energy as a service essentially is basically providing energy services to building, to residential customers, to domestic to commercial and industrial customers, in order to help them manage their energy requirements. Okay, so this is not something that is new in Malaysia. In Malaysia as well, there are several companies providing such services, including TNB subsidiaries like G-Sparks, okay, TNB ES in the past, as well as non-TNB companies like Yes Energy and so forth. Now, EAS is something that is definitely very valuable. As the price of electricity goes up, there is a need for us to actually start managing our energy use. Especially nowadays, I think all of us, most of us here are probably working from home or listening to it from home. And as a result, you start seeing the side effect of our electricity bill going up. Well, this is something that is positive for TNB's revenue, but nonetheless, it's something that we would like to help the customers with as well. All right. So in other words, to be efficient in the use of energy, And hence, energy as a service is something that represents a huge innovation that companies like Tenaga Nasional as well as other ESI companies will be interested to take up and to help everyone with. Okay, so for EAS to happen, of course, there are a lot of factors that need to be put in to support. One of the primary items that can be used to actually enable energy as a service is, of course, smart meters. So these smart meters is another thing that is another major innovation that is happening in Malaysia, that Tenaga Nasional is doing, and I'll talk more about this in a later slide as well. As a side note, one of the things that we noticed that in the future, along with the development of EAS, of course, we are seeing more smart cities and more smart homes being built and being deployed. Now, when we talk about smart home, essentially, in the eyes of Tenaga, for example, what we believe is that the home itself or the building itself will gradually incorporate more digital technology, more sensors, more intelligence, in order to basically change the way that we look at energy and the way we manage energy. So this can happen through the introduction of various technologies coming across the building. Things like, for example, the introduction of storage along with solar photovoltaics, perhaps the introduction of an electric vehicle charger at the home in order to charge your electric vehicle, the introduction of solar rooftops, for example. Nowadays, I'm sure you've heard of Tesla introducing solar rooftops. So we also have a version of that in Malaysia as well. Along with the thing that can enable all these things to happen, which would be the smart meter. So these are some of the things that we see that is going to happen in the smart city as more and more digital technologies is introduced into the cities. That's where you see the future building becoming even more intelligent, and that's where utilities as well need to start adapting and innovating in order to be able to integrate all these technologies into our business. Okay. Now, another technology that is also happening that is also enabled through smart meters would be something called the time of use. Now, the time of use is something that is already available in Malaysia. However, it's only available for certain segments of customer segments, namely the commercial and industrial customer. How it works, of course, time of use essentially is referring to the fact that electricity tariff will vary depending on the time of that is being used. So obviously during the peak hours, it will be more expensive. During the off-peak hours, it will be cheaper. There are plans to introduce time of use for domestic customers, you and me, for example. But this will only happen once we have smart meters in place. And right now, these smart meters was starting to be deployed in Klang Valley and is gradually planned to be expanded nationwide over the years. Okay. So it all started, of course, with a pilot study conducted by Tenaga in the past, but we have also done similar pilot studies on time of use, where we actually did a study back in 2016 on the customers that in Melaka and Putrajaya that has been installed with smart meters in order to study their behavior and to understand what they think about time of use. And from what we learned during the time of use pilot that was conducted on these smart meter customers, there was definitely a favorable response when time of use was introduced back then. Okay. Now, going back to the earlier slide, if you take a look at the innovation coming across, there are two other pillars that we can look into, namely on the market design as well as on the system operation phase. Now, the market design part, I think I will only cover on the time of use because there are other various, because that is the one that for us is the main one that will be happening in the near term. However, of course, you can also argue that there are other innovation happening in the market design. But for us, what we see is that this is happening probably at a slightly further horizon down the road. Things like, for example, the introduction of innovative ancillary services, okay, frequency response to basically to incentivize the operation of the provision of such services. The last part will be on the system operation, namely how the system operation, in other words, operating the system of network in Malaysia will change as we innovate. So one of the things that we are seeing that's coming across will be that the role of the distribution system operators or the role of the distribution network operators will be gradually shifting and evolving in order to meet the changing, the rapidly evolving technology out there. Now, to go into this a bit more further, this is something that is already happening with one of our major divisions, namely on the distribution side. So what distribution is seeing, of course, that they understand that their future role is not just being a network operator, but that they have to take on two additional roles, namely to be able to integrate all the various energy that is coming into the mix. Not, in other words, not just the energy coming from the power plants, but also the energy coming from the distributed energy resources, the renewable energy, and so forth. And the third function that it is that the end sees distribution sees itself taking up would be that of a open market facilitator. In other words, when if the retail market is opened up at a later stage, the distribution network is able to cope and able to support and provide the best services in order to manage the different requirements of the retail companies out there. Okay. The last but not least, before going any further, there is also something that's happening at the grid. One of the key technologies that's being introduced will be on what we call as dynamic line rating. So dynamic line rating essentially is the active bearing of the presumed thermal capacity for overhead power lines in response to the different ambient conditions, the environmental as well as the weather conditions out there. Essentially, in a nutshell, the transmission lines that is running overhead essentially has different would vary in terms of their ability to carry current, something called the ampacity, and this is in a way affected greatly by the environmental conditions of the transmission lines, based on, for example, the ambient temperature, the amount of sun that's shining, the wind speed, as the wind direction, and many more. So in order for TNB to manage this transmission lines well, dynamic line rating technology is something that needs to be introduced, and is an innovation that needs to happen, and it can only happen with the introduction of digital technologies, namely sensors, along with the analytics and the ability to model the data in order to ultimately implement this technology to enable the transmission lines to be operated in a more efficient as well as a safer manner as well. So this is something that GRID, one of the core divisions in Tenaga Nasional, is doing right now. So they've been working on something called a substation digital intelligent infrastructure, which essentially is an open data platform that enables them to collect and model the data in order to form the required models to support DRL. Right now, this has only been implemented in one of our major transmission lines at the 275 kV Aitawa and to Pantai Remis line. However, there are plans for grid to introduce this to other critical overhead lines in the coming years. Okay. Now, I did talk about digitalization, and this is something that Tenaga Nasional is definitely very keen to take up, and is already doing it at different degrees across the value chain. So this is just a snapshot of what's happening with regards to digitalization within Tenaga Nasional, coming from generation to grid to distribution to retail, even to the corporate division, as well as coming across the entire Tenaga. So obviously, I cannot go into all these technologies. There's all these innovations that's happening. So let me just take a couple of snapshots just to highlight some of the key examples that's happening. All right, so I'm 40 minutes down my presentation. I'll try to speed up this to allow for more Q&A. Let's take a look at the what we call the core divisions, the core the value chain. All right, so starting with generation. So what we see when we talk about digitalization in the generation segment, essentially at the end of the day is to help drive the efficiency of the power plants. Okay, how the power plants can be operated in a more reliable, in a more intelligent, and a safer manner as well. And to this extent, digitalization is something that definitely can help. I do recall what Prof. Vinesh mentioned earlier in the opening address about people centricity, location independence, as well as resilience. This is something that digitalization is definitely helping and definitely required in our nation's power plant as well. And what we see when we talk about digitalization in the power plants would be in the areas of helping to optimize the power plant performance as well as its production. In the areas of margin improvement, in other words, how we can actually improve the utilization of our fuel, our heat rate, how we can actually manage our power plants in a more smarter and better manner, as well as in the area of business sustainability and environmental sustainability. In other words, how do we actually digitalize our power plant in order to help bring down the emissions and also the impact on the environment? Okay, so there are many use cases that our generation counterparts are currently looking into, and we believe that is happening across the ESI as well, or other power plant operators out there. Things like, for example, how do we optimize our thermal plant heat rate? Okay, the setting up of a digital war room in order to manage all the various streams of data that's coming across, to make sense of it, and to come up with a model that will allow us to optimize our plant performance. To give an example of innovation happening at our generation, one of the things that I want to highlight would be on the digitalization of our war room. Okay, so for each of the generations power plant, there's actually a war room that has been constructed and this has been digitalized as well in order to allow a better and finer understanding of the way our power plant is operating, to look at the various parameters that the plant is operating at. Okay, so this is happening not just at the thermal plants, but also at our hydroelectric plants as well. And this is something that is projected to continue to grow. You know, the thing about plant war room digitalization, of course, is there's a need to introduce a lot of sensors. But the good thing about power plants is, by default, there is a lot of sensors there. Just that getting the right ones and getting the right data in, and actually coming up with the models to understand it, that is the challenging part. And this is that is where the innovation needs to take place. Now, on the transmission segment, one of the endeavors that our grid counterparts have been embarking upon is something called the Grid Digitalization Intelligent Infrastructure Program. Essentially, is a term that my grid colleagues are using in order to digitalize the way that they are operating and managing the grid. And it can be generalized into 3 different segments, namely how they can manage their assets, the transmission lines, their substations, their transformers, the switchgears in a more intelligent manner through the use of digital technologies. Secondly, how can they empower their workforce through digital in order to make them more productive, more efficient, and very importantly, safer. Okay, and last but not least, intelligent grid operation. In other words, how can we build the models and understand our grid better through digital and through data analytics in order for us to operate our grid in a more intelligent, in a safer way, as well as in a more reliable and cost-efficient manner as well. At the same time, bear in mind that when the more renewable energy is being introduced into the grid, the more there is a requirement to digitalize the grid in order to be able to understand and to react automatically to any variations coming across these so-called the VREs, or variable renewable energy. Okay, so some of the innovation that's happening at grid division, I mean, these are just a couple of innovation. I mean, there's just so many things that's happening in the grid division right now. For example, they have introduced, they are using something called ArcGIS, which is a powerful geospatial information system tool, along with the use of unmanned aerial vehicles, or UAVs, with LiDAR technology in order to quickly collect transmission line and other land data in order to support and build and populate the GIS to enable a quicker completion when it comes to the surveying of the transmission line site. Okay. The second innovation, just to give example, would be the use of a smart glass. So this is something that is being worked upon together with our one of our subsidiaries from called ILSAS, which is our internal training agency, where GRID is using smart glass as an augmented reality tool in order to enable its experts, instead of having to go down to the field all the time, to be able to remotely assist the on-site field crew to do their work in a safer and standardized way. Okay, and last but not least, the use of asset performance management system, which is a platform that was developed to assess the transmission asset health as well as risk, and ultimately to be able to provide advice based on the criticality and also the failure risk of each of the assets in order to come up with the optimal maintenance regime intervention. Okay. The third one I want to talk about quickly will be on our distribution level. So this is something that is happening in conjunction with the smart utility framework that our distribution colleagues are looking into. All right. So essentially, it can be divided quickly into 5 different areas of asset management, work management, grid operation, energy management, as well as customer management. Now, there are various innovations that's happening across distribution. So when I talk about distribution, just to clarify, distribution is basically referring to the network at the medium level, medium voltage level as well as the low voltage level. Now, some of the innovation that's happening, a lot that is being catalyzed through digitalization, would be in the area of asset intelligence. You know, the way that the network is designed, the way our street lights actually operate. Okay, so there's something called smart street lighting. In other words, street lights that can be managed and also to be operated remotely. In terms of the metering infrastructure, through the introduction of smart meters, the way that the workforce, the field crews actually do their work, this is also being greatly impacted through digital, as well as one particularly interesting area would be the detection of what we call as non-technical losses. So non-technical losses refers to losses that happen. In other words, not because of technical reasons, but because of non-technical reasons. For example, due to data theft, due to energy theft, and so forth. So this is something that can be better managed through the use of analytics in order to automatically detect where some of the possible non-technical losses are happening, and to enable distribution to take action on it. Okay, just to very briefly mention about AMI. AMI stands for Advanced Metering Infrastructure. So essentially, it's a jargon that's used to, basically we are talking about smart meters. So smart meters is definitely one of the key digital technologies that is happening across Malaysia. This is something that Tenaga Nasional really wants to champion and really wants to bring across, okay, for Malaysia. Because through the introduction of smart meters, so many different features can be provided to the end users like you and me. Things like, for example, auto billing, to time of use services, to automated outage notification, high consumption alert. For example, if your electricity bill within a month is above a certain threshold, we can send you a warning to say, hey, you better take note of how you're using your electricity, yeah? And things like that. So AMI is one of the key enablers that Tenaga wants to drive through, and this is already happening right now in Malacca. I believe it has been fully deployed, right? And now we are moving into the Klang Valley, okay, into KL, Selangor, Putrajaya, Cyberjaya, and in the near future, then next year we will be moving further into other states, Penang, Johor, and subsequently to the rest of Malaysia. Okay. Distribution automation is another technology that is also enabled through digital as well, digital and also non-digital. Okay, essentially is the way that allows the substation to automate the restoration of supply. So with the introduction of distribution automation, what we see is that the average time to restore any electricity outage has been greatly reduced, and this is something that is also being implemented not just in in the previous years, but in the subsequent years to come. Okay, last but not least, just a quick one on retail. Now, retail is basically the one that we see will need to greatly innovate. In other words, when we talk about the retail market, is talking about the part of the utility that is serving the end users, the end customers like you and me. Okay, so to that sense, retail is focusing on three different digital pillars, namely the way that they handle customer interaction, okay, the way that they provide solutions. In other words, not just through the traditional ways. For example, the bills can not need to be served through a paper manner, okay, but it can also now be served through digital. And last but not least, a digital enterprise. In other words, how digitalization can enhance customer and employee experience in delivering customer centricity. Okay, so there are various interesting solutions, digital solutions that are coming along in our retail pipeline, from all the way from MyTNB. So MyTNB, of course, is the de facto app that is being used by all of us in Malaysia, if you're a Tenaga Nasional customer, so that you can use MyTNB. If you don't have it right now, make sure you download it. So it's something that's really useful and that can help you to basically understand and be aware of your electricity usage. And it will become even more useful once smart meters come into place. Okay, there are so many other customer solutions that will be introduced over the years. Okay, so I will not go into the details for each one of them. Essentially, at the end of the day, it's all about the customers for retail, how we can actually improve experience and also provide a better service quality to the customers. Okay, so I'll stop here right now to have a bit of a Q&A, everyone. But just to summarize what I presented. So, guys, in the past, there is a lot of perception the electric supply industry is something of a bit of a turtle or tortoise when it comes to innovation. And when we compare to our brother from the telecommunications sector, so on the picture here, you can see Alexander Graham Bell, the inventor of the telephone, as well as Thomas Edison, the inventor of the light bulb. Now, if we were to put them in the same room and get them talking about how their respective industries have developed over the years, back then, I think Thomas Edison would be a bit embarrassed because telco industry has been growing at such a rapid pace and has been rapidly deliberating in order to adapt to all the different technology innovations. But nowadays, I can safely say for sure that the electric supply industry is also doing so. Perhaps not at the same pace, but it's definitely happening at a very much rapid pace as compared to the old days. And if you talk to Thomas Edison nowadays, if he was alive at this moment, probably he'll be a bit prouder about that as well. Okay, so with that, just to summarize, innovation is happening in the electric supply industry. It is definitely something that is being embraced by the utilities, by the companies in ASI, in Malaysia, as well as globally. And it's something that we need to continue doing in order to really bring the best to you and me, to all the customers, to all the people out there. All right. With that, I will stop here and go into a Q&A. Thank you.
Hi. Thanks, Woon, for your presentation and keynote. And I believe your keynote has definitely benefited many of the audience and participants here in the field of electricity supply industry with your innovation. We have received quite a lot of interesting questions for your address. So maybe I pull out the first one. Are you able to see the screen?
Yes, I can.
Yeah.
Okay, so perhaps let me just read the question directly. So it's a question from Afiq. Thanks, Afiq, for your question. Why energy storage market or research is increasing this decade? Why is there a demand or the motivation behind? That's a great question, Afiq. Now, with regards to energy storage, as you rightly pointed out, it's not something new. All right. So back in the good old days, in the 90s, okay. So even in the start of the decade, I mean, energy storage has always existed. In the Western world, for example, there's something called pumped hydro. Pump hydro is basically the storing of electricity in the water, okay, and it can be controlled and released as and when required. And it acts as a form of storage. And in fact, the biggest energy storage concentration is actually still located within pump hydro in terms of the megawatt hour. Okay. Now, what we are seeing nowadays, that why is there interest in energy storage, is because primarily it's due to the increase of RE. Now, with the introduction of renewable energy, particularly variable renewable energy, so there is a need to manage the intermittency coming across with such energy source, and that's where energy storage really shines. Okay, because it helps to manage that by storing the electricity, by storing the energy when you do not need it, when there's an excess amount of energy in the grid, and allowing it to be released, used when there is a need or the demand for it. And that is primarily one of the main reasons why energy storage is market research is growing. Of course, along with that, it's not just on the electric supply industry. We know, as I mentioned earlier, electric vehicles is also growing in terms of popularity and adoption. And the primary engines, so-called mechanism that allows electric vehicle to work is basically the batteries itself. And along with the development of the batteries in the EV, there is a spillover effect as well to the electric supply industry. And hence, that's why you see right now energy storage is something that is really growing importance, and definitely something that all companies in the ESI need to sit up and take note of. And likewise, of course, in terms of research, is something that I would expect the universities to really go into and take it up. Yeah.
Yeah,
thank you,
thanks,
Afi.
Mr. Woon. I believe, thanks for your enlightenment. I agree with you that energy storage is one of the key to address the intermittency of RE. And this linked to our next question, why is the RE mix low or slow in Malaysia? Any economic or technical challenge?
Okay, thank you, JX. Thank you, Tai, for that question. Why is the RE mix low or slow in Malaysia? Now, make no mistake about it. I think the government wants to introduce RE into the mix. Okay. However, there are, as you rightly pointed out, there are technical challenges. Now, in the earlier days, of course, the cost of deploying RE, especially solar in Malaysia, is a bit expensive due to the price of solar. But the price of solar has gone down to such a tremendous extent, especially due to the mass manufacturing of solar photovoltaic cells, even in Malaysia. Okay, so this has been growing globally, and hence with volume comes the decrease in price as well. So in terms of economy side, in terms of the cost of deploying solar PVs, it has definitely gone down. The challenge is that, if you recall earlier, I talked about the energy trilemma. So while there is definitely an interest to introduce more RE into the mix, we need to take into account the fact that it's not just the sustainability angle of the energy trilemma that needs to be managed. We need to look at the security. In other words, the energy security as well as the energy economics. So in other words, we do not want to be introducing RE to such an extent that the price of electricity for everyone else becomes more expensive, and at the same time, electricity, the grid itself becomes harder to manage, because as you have more RE coming in, it becomes harder to dispatch. Dispatch means to manage the supply of the electricity, and supply and demand of the electricity, and that's where you start to see the need to actually reinforce the grid through the introduction of storage, through the introduction of digital. So these are the other angles that the ordinary Joe does not see. So a lot of people will say that, hey, let's just go ahead with RE, get more RE into Malaysia. Let's kill off all the coal plants. But the fact is, and the fact still remains, that in Malaysia we still need our thermal power plants at this moment. If we were to switch overnight to RE, I can tell you the grid will not survive, just like that. Because the problem with RE at the end of the day is that, when the sun is shining, all is good. You get a lot of electricity, a lot of energy. But what happens when the sun doesn't shine? Do you want to see your shower stop working, your computer's turning off? No, you still want your electricity to run, and that's where you need to start introducing all these technologies to complement RE, and also to make sure that we continue to have some base load coming across in our thermal power plants in order to make sure that when the sun doesn't shine, you and me still have electricity. Okay.
Yeah, thanks, Woon. So basically, it's the cost and also the intermittency challenge that, yeah, so we have to consider. Yeah, thanks for the enlightenment. Right. Yeah, so any other challenge like noted by the next question you can see, where RE is increasing will be a threat to utility or oil and gas company, including TNB?
Well, that's a great question, Krishna or Jogi. Right. So, yeah, I mean, RE, I mean, in the past, when we talk about RE, I mean, of course, Tenaga Nasional being a provider of electricity supply, I mean, there's the concern that more and more customers will gradually pasang install solar PVs on their rooftop, and then eventually one day they will decide, hey, I don't need Tenaga Nasional anymore. Let's just go off grid. Yeah, power to you. Okay, so but that does not happen because that has not happened a lot. Let me just add, due to the simple fact that again, RE is intermittent. It is not something that can be supplied 100% the whole day, 24/7. Okay, and during those times at night, for example, you still need electricity supply, and hence, that you still need to be on grid. In other words, connected to the national grid as well, and continue to have electricity from there. So my answer to that question is, in a way, is both a threat as well as an opportunity. Okay, so Tenaga Nasional, in fact, if you are aware, our aspiration is to be the leading provider of sustainable energy solutions in both Malaysia as well as globally. And of course, when we talk about sustainable energy solutions, RE is one of them. It's definitely something that we embrace. There is just no running away from it. Let's just put it that way. Yes, if the entire world suddenly switch to RE overnight, it will be a massive threat, not just to utility, but to the stability of the grid, to our network. But it's something that we believe will definitely need to happen, and we see it as an opportunity and not as a threat. Yeah, thank you.
I think, Woon, I liked your insight where you see the threat not only as a threat but as an opportunity. Thanks for your enlightenment. We'll go to the next quickly. So yeah. So for the insightful info, what is the government latest initiative in increasing EV charging station and bringing EV cars like Tesla and NIO?
Okay, thank you, Mr. Lai, for that great question. Now, electric vehicles is something that is really interesting for the Tenaga Nasional, and it's a no-brainer. Okay, you look at the term electric vehicle, and Tenaga Nasional is in the business of providing electricity. So of course, it goes without saying that we would like to see a faster shift to electric vehicles in Malaysia. Now, when it comes to government initiatives, what we see is that there is a bit of slowness in this transition, in that sense. Perhaps it's due to a lack of leadership when it comes to driving electric vehicle adoption in Malaysia. But when it comes to government's initiatives, there doesn't seem to be a lot of clear-cut policies to incentivize and to support the transition to electric vehicles due to a variety of factors. Okay. However, what we hear is that of late there has been there has been renewed interest coming across our government when it comes to driving electric vehicle in Malaysia, including bringing in additional more mass market or mainstream models like Tesla, maybe Model 3, and NIO as well. Okay, you might be aware, for example, that Malaysian Green Tech is looking at introducing something called the Low Carbon Mobility Blueprint. So this is something that is currently being deliberated within the ministries. And of late also, we've been hearing that there are other programs being introduced in order to speed up the adoption of electric vehicles. So yeah, this is something that's definitely going to happen. And what Tenaga wants to do also is that we want to be able to engage with the government to actually work with them to see what else can Tenaga and the industry do in order to increase the number of EV charging stations in Malaysia, to build that up. and also to, in a way, to break the chicken and egg situation when it comes to whether or not we bring in the charging stations first, or we bring in the EV first. So this is something that Tenaga Nasional is keen to explore. Great question, thank you.
It's a chicken and egg.
Yes.
Yeah. Okay, due to the time, we have maybe another 2 more questions for you
Sure.
before you move to the lunch break. Yeah, so this is a long question. So it's about the building. Yeah, perhaps you can have a look. And it's saying that the energy intelligence future building comes at an additional cost. So the additional cost will be a hurdle on the selling and buying point of view. And the cost is the hurdle of technology development in buildings. How will this be addressed, especially in developing nation, maybe in Malaysia, or maybe in a middle and low income group nation?
Thank you, Shankar, for that very intelligent question. So, agreed. I mean, when we talk about technology, one of the challenges of technology is not just the technology itself, but it's also the cost. Now, when we talk about energy as a service, when I talk about energy as a service earlier, yes, you are right. There is a cost to be factored in. However, at the end of the day, it's all about the ringgits and cents. It's about the economics of things. So, by the question is, through the introduction of all these technologies, of all these services, are you actually bringing down the cost? So the question is something that can be posed to all the building owners out there. So at the end of the day, through the introduction of these technologies, are you actually bringing down the cost of your electricity bills, for example? So if you are doing that, then and it's definitely the reduction in cost definitely outweighs the cost of implementing the technology. So why not? Correct. So at the end of the day, I think so when you talk about the cost, is again working out the return of investment. So obviously, implementing smart building technology does not need to happen to all buildings. For example, if you are in a building that uses very little electricity, I mean, there's no point putting in all this technology to manage and bring it down even further. However, if you're in a factory, or if you're in a commercial building like a shopping center, an office building, electricity bill is quite can be quite substantial, and that's where it makes sense to introduce all this energy intelligence in order to manage the way that the building is operating, to manage the way that your home is actually consuming electricity. And so at the end of the day, I think it's basically is just working out whether or not it makes sense for you to invest the technology, depending on the returns that you are getting from that. Now, whether or not how this can be accelerated in developing nations, I think this is something that can be done through the assistance of the governments. So the government can introduce certain energy efficiency measures in order to help to bring down the cost of introducing energy efficient mechanisms. So this is something that has happened in a lot of other countries. In Japan, for example, they have actually introduced energy efficient appliances. So if you purchase energy efficient appliances, you can actually bring down the cost of you can actually do it at a subsidized rate. So this is something that can be explored with the government. Yeah.
Yeah, thanks, Woon. I agree with you. I think everyone has a role to play perhaps in introducing the technology. Someone has to introducing the policy, cutting down the cost, etc. Yeah. Last but not least, maybe let's ask. Okay, let us have one last question. Interesting question.
Okay.
Yeah, I'm also interested with this question before we end this session today.
Oh.
Yeah. So is TNB open to providing data for universities to embark on related studies to address some of the topic you highlighted? And if so, how do we go about this?
All right, thanks, Jacqueline, for your interest in working with Tenaga Nasional to study some of this innovation and some of these technologies. I can say for sure that Tenaga Nasional is keen to explore such opportunities. We do have our own university arm as well, in the form of University Tenaga Nasional, as well as Tenaga Nasional Berhad Research and Development, TNB R&D. Okay, so. And likewise, of course, we can also provide some of this data. However, do get in touch with us, and I will. You can actually. I'll actually share my email address later, So if you are interested to contact me or my counterparts to talk about these opportunities, just drop me an email. Happy to help or to redirect to my colleagues at the other at Uniten or TMBR in order to assist with that collaboration. Okay. So yes, definitely looking forward to that.
Okay, thanks, Mr. Woon. Yeah, for those who are interested, if you have any further question, you can write to us at siet@apu.edu.my, or you can directly write to the speakers. Yeah, so Mr. Woon, I think that the time is up, and we do not.
Yep.
We thanks for your precious time, even though you are working in industry TNB, and you still take your time and to share your insight and deliver your keynote to enlighten all of us here. We believe that the audience, the students, or even the industry players, the researchers are very well benefited with your innovation insight in electricity supply industry. So with that, we thank you, Mr. Woon.
Thank you. Thank you for having me.
Yeah, thanks. Bye. Okay, guys. So here we comes to the end of the SIET 2021 session, keynote session. If you have missed out any keynote session that you are interested with, either Professor Kyo Beum Lee in reliability in powertronics and drives, or by Mr. Woon from TNB in innovation in electricity supply industry, don't worry. You can watch this session. It is available in the Facebook page and also as well as in our YouTube channel. If you are interested, if you have any further question, you can write to us in siet@apu.edu.my. Once again, we thank all of the participants, we thank all of the viewers, and we hope that your participation and your commitment make the world a better place with the research, solution, and ideas in sustainable development with engineering and technology. With that, we end our SIET 2021, and we hope to see you in SIET 2022. Please submit your papers, your ideas, and share your findings with us to encourage and to promote sustainable development with engineering and technology. With that, we end our session. Thank you and see you next year. Bye-bye.